Volcanics region covers approximately 10,000 square miles of central Idaho. The region is centered in Custer County and extends into Lemhi, Valley, and Blaine counties. Minor portions of the region fall within several other counties as well. The town of Challis, Idaho sits roughly at the center of the region, which extends from Salmon, Idaho in the north to Ketchum and Stanley in the south and southwest. The rocks in the Challis Volcanics region were formed during the early to middle portion of the Eocene epoch between about 52 and 39 million years ago. The bulk of the rock was formed during eruptions between 51 and 45 million years ago. To put those dates in perspective, the age of the dinosaurs extended about 66 million years ago, so the dinosaurs were extinct for 15 million years before the volcanic eruptions that defined the region occurred. Conversely, the first hominids appeared 2.5 million years ago, more than 40 million years after the bulk of the rock formation had occurred. The Challis volcanic field is broken into two regions, the northern field and the southern field. The reason there are two different regions is twofold. One is because the lavas were deposited onto a very irregular surface, and secondly, they happened at different times. Ages are partially determined by looking at the stratigraphic relations. This is done by comparing rocks found local to the Challis region and similar rocks of known ages found in neighboring regions. The similar rocks can reasonably be assumed to have formed at the same time if the characteristics of the rocks at each location can be proven to be alike. Another method for age estimation is based on radiometric dating of argon samples taken from the southern region. Radiometric dating of argon isotopes is accomplished by measuring the proportion of argon-40 to argon-39 present in the sample. The half-life of the argon-40 isotope is approximately 1.25 million years. Let's start by looking at the rocks located in the northern field, where the most voluminous volcanism and plutonism occurred. The oldest rocks are most dominantly andesite lava flows. Recall, andesite is an intermediate igneous rock with an aphanitic to porphyritic texture, meaning that the grain is fine to a mixture of grain sizes, indicating that the magma partially cooled below the surface, giving time for the crystals to grow before erupting onto the surface. We can compare the lava flow of basaltic lava, like in Hawaii, to this type of lava. Since andesite has a higher silicon to oxygen ratio, its viscosity is also greater. And as a result, this type of lava appears blockier when compared to the basaltic A'a and Pahoehoe surface forms. The next layers deposited are the ash flow tuffs. They have an intermediate composition between dacite and rhyolite. And finally, the youngest layer deposited in the northern field is a result of rhyolite domes and plugs, which over time have been exposed through erosion. Much like this pictured rhyolite dome called Mora rock found in California. Next, the southern Challis field is composed of volcanic and sedimentary deposits and are subdivided into four stratigraphic packages. The lowest layer is the basal Challis conglomerate and tuff breccia. The clasts are larger than sand size, but vary by the amount of their rounding. This deposit helps geologists figure out topography before volcanism started, and also helps set a minimum age for the initiation of volcanism. The next layer is an andesitic lava flow and tuff breccias, which were deposited by lahars. Source vents for these lavas are difficult to identify because clear volcanic facies patterns are absent in most areas. Evidence suggests that many of these flows erupted from fissures rather than point sources. Ash flows are layered on top of the lava flows. Sheep Mountain and Porphyry Peak are the inferred sources, but no calderas have been found there. Finally, dacitic to rhyolitic subvolcanic intrusions compose the final layer. Intrusions are the result of magma at shallow depths in the crust, often directly related to overlying volcanic geology. This underlying geology gives us some major structural features like calderas, cauldrons, dikes, and plutons. This region later experienced tensional stresses that caused other features like normal faults and grabens. Prior to the Eocene, the Farallon Plate was rapidly subducting beneath the North American Plate. Little of the Farallon Plate remains today, but ruminants include the Farallon Islands off the coast of San Francisco and the Juan de Fuca Plate located off the coast of Washington and Oregon. Originally, the Farallon Plate subducted at a shallow angle, and the subducted slab extended eastward as far as the eastern Wyoming. However, about 56 million years ago, the subduction rate slowed and the subduction angle steepened. The zone of volcanic activity created by the plate's subduction originally had been east of Challis, but as the subduction rate changed, the volcanic activity zone migrated west, creating a large area of volcanism throughout the northwest U.S. and into Canada. The Challis Volcanics region is a portion of the larger volcanic activity. As a result of the migrating volcanic zone, the rocks on the eastern side of the region are older than those on the west. The subduction zone continued to move westward over time, creating other geologic regions. Today, the volcanic zone is located beneath Cascade Range of Washington, Oregon, Northern California, and British Columbia. This mountain range is composed of a string of volcanoes created by the same plate collision as the Challis Volcanics group. The igneous rock building in the Challis Volcanics region occurred during two phases. In the first phase, granite formed 3 to 4 miles below the Earth's surface. In the second phase, as the volcanic zone created by the subducting plate moved westward through the region, surface volcanoes appeared and large amounts of intermediate and mafic lava flows, as well as tuffs and ash, covered the region. Intrusive volcanic activity continued producing dikes, sills, and domes of rhyolite. Many years after the initial formation of rocks, during the Pleistocene epoch, large portions of the Challis Volcanics regions were glaciated. The Pleistocene epoch started roughly 2 million years ago, about 37 million years after the rocks of the regions were formed, and lasted until approximately 12,000 years ago. During the Pleistocene, the Earth was significantly cooler than it is today, and repeated glaciations occurred, at times covering nearly 1/3 of the Earth's current surface with ice. About 20,000 years ago, the Wisconsin glacial maximum occurred, and then the last of the great ice sheets began to retreat from the northern U.S. In Idaho, the continental ice sheets had only covered the extreme northern portion of the state. However, during the period, much of central Idaho's higher elevations were covered with alpine glaciers. The glaciers in Idaho are estimated to have lasted until as recent as 6,000 years ago before finally retreating. Evidence of glaciation, such as the presence of U-shaped glacial valleys, can be seen in the southern portion of the Challis Volcanics region in the Stanley Valley. Although the region was glaciated in higher elevations, today the primary drainage pattern throughout most of the region are detritic, and the valleys primarily show the typical V-shaped cross-section associated with river valleys instead of U-shaped glacial valleys. The primary drainage for the region is the Salmon River, which starts in the southern portion of the Challis Volcanics region and flows north and east through the region before turning west and flowing west to the Snake River, where its flow is measured at 313 cubic meters per second. The region has some mineral resources, including gold, silver, copper, lead, zinc, mercury, molybdenum, and antimony. Productive gold and silver mines existed around the Trans-Challis Fault Zone, a 40-mile wide, 135-mile long zone that runs from north of Challis southwest towards Idaho City and primarily within the Custer Graben. Today, several ghost towns, including Clayton, Sunbeam, Bayhorse, and Bonanza, are spread across the Yankee Fork Mining District, the main region where the mining has occurred. The Challis Volcanics region is also home to the Boulder White Cloud Mountains. Today, these mountains, which are part of the Sawtooth National Recreation Area, are a popular recreation destination for hikers, bikers, and motorcyclists. For the past 10 years, a plan to further protect the natural beauty of the Boulder White Clouds, while offering development for small towns in the area, has been proposed. The Central Idaho Economic Development and Recreation Act, or SIERDA, has support from many of Idaho's politicians. However, several recreational and environmental groups prefer alternative plans that include designating much of the area a national monument, while others prefer to keep the current National Recreation Area designation. In all cases, Idahoans agree that the beauty of the area needs to be preserved for future, but it remains to be seen what form the protection will take. Recently, the town of Challis has been experiencing a series of earthquakes, including a 4.9 magnitude quake, 33 quakes in excess of magnitude 2.5, and more than 100 smaller quakes in the spring of 2014. The tremors have not been centered on the Lost River Valley Fault. This fault produced a 7.3 magnitude earthquake near Mount Bora in 1983. It lifted the ground at the fault 14 feet. Additional seismometers have been brought into the region to study the quakes and possibly determine if these tremors could be predictors of Idaho's next big quake.